This problem, we have the limit of the tangent x minus secant x as x approaches pi over 2 from the left. The tangent x approaches infinity. The secant x approaches infinity as x approaches pi over 2 from the left. As you can see from the graph, the tangent graph, with the bounds at negative pi over 2 and pi over 2. And the secant is the reciprocal of the cosine. As x approaches pi over 2, the cosine approaches 0, so the reciprocal approaches the infinity. We are going to rewrite the expression into the quotient form. The tangent x is the same as sine x over cosine x. The secant is 1 over cosine x. And then we're going to combine these two fractions into one with the common denominator, which is the cosine x. The numerator becomes sine x minus 1. Check the indeterminate form. This one we get 0 over 0, which is the quotient indeterminate. Therefore, we can apply L'Hopital rule. Find the derivative of the numerator divided by the derivative of the denominator. Then we get the limit of the cosine for the numerator divided by negative sine x for the denominator. Take the limit as x approaches pi over 2 from the left. Cosine of pi over 2 approaching 0, sine of pi over 2 approaching 1 with a negative sign. So the value is 0 over negative 1 or just 0 for the result. This example, we have the limit of the x minus square root of x squared minus 3x. As x approaches infinity, we have the indeterminate form as a difference of the two infinities. We're going to have to adjust the difference into the quotient. So on the side, working on the x minus square root of x squared minus 3x, the radical square root of x squared minus 3x. From x squared minus 3x, we can write it as a product of x squared and 1 minus 3 over x. And then simplify the radical into the form of the x multiplied by square root of 1 minus 3 over x. Now we have the common factor x and x. Write it as a product of the x and 1 minus square root of 1 minus 3 over x. As we started with the difference, at this step we have the product. Now we are going to change the product into the quotient. 1 minus square root of 1 minus 3 over x remain as it is. And the x here, we're going to rewrite it as the reciprocal of 1 over x from the property that x equals 1 over x. Then the product now becomes the quotient of 1 minus square root of 1 minus 3 over x divided by 1 over x. So back into the main problem. Limit x approaches infinity. The expression now it is 1 minus square root of 1 minus 3 over x divided by 1 over x. For our convenience, we're going to introduce another notation. For example, let a be 1 over x. As x approaches infinity, a approaches 0. So we are rearranging the expression in x to be the expression in a. Now the limit becomes a approaches 0 for the numerator as 1 minus square root of 1 minus 3a divided by a. As we have the quotient form, we're going to check the indeterminate, whether it is in the quotient form of the 0 over 0 or not. As a approaches 0, in the radical, it becomes 1. So 1 minus 1, the numerator is 0, denominator is 0. That means it is good to use the L'Hopital rule to evaluate the limit value. So apply the L'Hopital Find the derivative of the numerator divided by the derivative of the denominator. This time it's going to be with respect to a, not with respect to x. The derivative of the 1 with respect to a is 0. The derivative of the square root of 1 minus 3a is 1 over 2 times square root of 1 minus 3a divided by negative 3 and divided by 1 for the derivative of the denominator. As a approaches 0, simplify the numerator as is divided by 1. Now the expression becomes 3 divided by 2 times square root of 1 minus 3a and take the limit as a approaches 0. Replace the value of the a with a 0. Since we don't have the 0 denominator case, direct substitution can be applied. We have 3 divided by 2 square root of 1 minus 0, or the answer is 3 over 2. Now we are going to find the limit of the cotangent x minus 1 over x as x approaches 0. Check what form of the indeterminate of this problem. For the cotangent x, this is the same as cosine x divided by sine x. As x approaches 0, the first term approaches infinity, as well as the second term. So we have the difference indeterminate form. We are going to rewrite the difference into the quotient by combining the two fractions to have the same denominator. The common denominator is x multiplied by sine x, so the numerator becomes x multiplied by cosine x minus sine x. Check the indeterminate form one more time. As x approaches 0, the numerator approaches 0. Denominator also approaches 0. So then we can use L'Hopital to find this limit. Find the derivative of the numerator divided by the derivative of the denominator. This time we are going to apply the product rule to find the derivative. The numerator becomes x multiplied by negative sine x plus cosine x from using the product rule of the first term of the numerator. The second term becomes negative cosine x divided by the derivative of the x sine x. After applying the product rule, we get sine x plus x times cosine x. Simplify the numerator. We write it as the limit as x approaches 0 of negative x times sine x divided by sine x plus x times cosine x. As we see, this quotient still approaching 0 over 0 as x approaches 0. We have to apply L'Hopital one more time. As x approaches 0, the derivative of the numerator becomes negative sine x minus x cosine x. The denominator, the derivative is cosine x plus cosine x minus x sine x from using the product rule, applying it to the second term of the denominator. The cosine x plus cosine x becomes 2 cosine x minus x sine x for the denominator. The numerator cannot be simplified. Now we are going to take the limit as x approaches 0. Sine of x approaching 0. The second term as x multiplied by cosine x as x approaches 0. This term goes to 0 as well. Cosine of 0. The 2 times cosine x will approach the value 2. X times sine x will approach the value 0. Therefore, this limit approaching to the value 0 over 2 or just 0.